So hi guys, good morning guys, all of you. And in the last session, we started indexes and up to the types of indexes, B-tree and bitmap indexes we discuss. Okay, and later on, simple indexes. Okay, when we called a simple index. Okay, and your B-tree indexes are different formats. We can go to design your B-tree indexes. Okay, simple, composite, unique, and functional basis. Okay. So these are the four types of what we called indexes we call in a B-tree format. So simple index, I think we discussed in the last class. Okay. So simple index when we called means when we created index object based on single column, so then it is called as a simple index we called. Okay. Now, and this is how we created and how the B-tree index will be arranging your data as per given condition value. Okay. Na? So in B-tree, what it was happened, so left side, okay, completely your uh, the left side values, okay, which always going to be less than values will be saving under in the left side category, and right side greater than or equals to values are saved under right side. So this is the way how one by one value will be saved in our B-tree format, how it was arranging here. And after arranging of data, later your Oracle server will utilize this facility by your server while retrieving data. Okay. So how we said here nowadays, and if you go to publisher, so who was published by textbook? Okay. So those publisher, what they will do, they will be preparing index page and they kept into textbooks. And those index pages we are using while you are retrieving the data. Okay. So same as here also, the B-tree indexes are preparing by your systems. Okay. Internal it was preparing as per your index facility. And after that, that index facility, whatever it was prepared by system, that was utilized by servers. Okay. Oracle server will be utilizing that index facility while retrieving the data from your table. Okay. So this is what the concept of indexes. Okay. And now this is first a simple index we called. In the same pattern, when you want to design, okay, composite index, how this composite index will be designed here. Okay. So composite index when we called as means, okay. So when we created an index object, so based on multiple columns, then we called as here composite index we called. And how it will be created means create index, and I want to give my index name. Okay. And table name. Okay. On table name of a column name. So here column name 1, comma, column name 2. Okay. And so on. Okay. So this is the syntax of your composite indexes, how to create it now. Okay. But here carefully observe the composite index, whatever we created now. Okay. Here multiple columns I'm passing here. Okay. So, but index, that means the B-tree indexes, they will be preparing. Okay. Means that I indexes when it was activated. It means that, so you can send any number of columns along with your, okay, the table name. But indexes can be, okay, perform, or index operations can be performed only the one column. That column is called as the leading column. So which is the leading column we called? That means the leading means the first position of column. Whatever the column in the first position, so that is called a leading column. And based on the leading column only, your indexes can be worked. Then non-leading columns, if I'm using while retrieving the data, then it is not allowed indexes. Okay. For example, let me see. Come to your database now. Okay, so this is our table. On this table, in the last class, we created one index circle. So that index, if I want to see, then we have one data dictionary. So what is the data dictionary here? Index name. Okay. So user underscore ind underscore columns is one of the data dictionary where table underscore name is equals to emp. So on this salary column, we created index I1. Okay, same as, and now I'm creating one more index here. Create index I number 2 on EMP table. Okay. Now here I'm passing here DEPT number, comma, job column. So on these two columns, that means here my index was created on multiple columns I created. Once you created indexes on multiple columns and see your index was successfully created, department number and a job. The I2, my index name. So that was successfully created now. Okay. But sir, when I want to call, okay, when I want to call this, okay, so how it was working, okay, means that leading column positions it will be used here. So based on leading column, it will be work. Okay. Suppose, for example, if you need to write the testing part here, suppose I'm writing, okay, select star from EMP. So where, so I'm using where DEPT number is equals to some 10 or 20, whatever it is. So whenever I want to use here, in my where class condition, I'm retrieving data based on department number column condition. And department number is called as a leading column. Okay, it's a first in first priority. Okay, this is called as a leading column. It is called as a leading column. So the leading column wise, that means based on leading column, I'm retrieving my, okay, department number data. So in this case, which one it was scan means your index scan will be performed. Your index scan will be performed. Yes or no? Your index scan will be performed here because leading column is, what is my leading column? Your leading column is nothing but first position of column is called as a leading column. So which column are you given in the first position? So that is called a leading column and remaining called as a non-leading column. So based on the leading column wise data retrieval is done, then internally it was performing index scan mechanism will be choose by your Oracle server. Okay. But same as if I want to say, okay, suppose I'm going to writing select a star from EMP where what we can say job is equals to, for example, I'm sending some clerk. So so here what it was happened here, I'm going to retrieving the data based on which column wise I'm retrieving here data, job column wise. But job column is not a leading column. Yes or no? Job column is not a leading column. When it is not a leading column means by default here which one is performed means here it will be performed, table scan will be performed. Okay, na? Table scan will be performed. Because when we created indexes on multiple columns, how the internally the mechanism is going to be happen means which one is there in the first position or leading column position. So based on leading column only, the indexes will perform. Okay. If you are going to non-leading column, if data retrieval, then internally the indexes are not activated by server. So by not activated by server means by default what it is here, table scan. So table scan will be performed. Okay. But the same thing, okay, if I want to send here, select a star from EMP. So where if I'm using department number 20 and job is equals to, I'm sending what now? Clerk. If I'm using the both combination of columns, okay, then definitely it will be index scan will perform. Why sir index scan will be performed means here the part of leading column is there. The part of leading column is there. So when you have the part of leading column, definitely it was first priority will give what now? Indexes. Okay, no? So in such a way, your okay composite indexes will be working. Okay, no? So this is that means here the point. What I'm saying here, the point is okay. in composite primary key, sorry, in composite indexes, index or indexes are activated, okay, based on leading column, wise. Okay, now, so this is what your composite indexes will be work. So next one is what now? Unique indexes. So unique indexes, how it was working here, observe. So when we called as a index is called as a unique index means, so when we created an index object, based on unique constraint, then we called as a unique index we called. Okay, now based on unique constraint, we called as a unique index we called. Okay, now syntax is observed. So when we use syntax, okay, what is the syntax for this? Create. Okay, I'm using a keyword is unique. So I'm passing index and give it your index name. Okay, on the table name of a column name I have to send. This is what. So now in this case, how the unique index, okay, will be working internally means, for example, let me see, I'm going to create one serial number, and if there is a no unique constant on this, so there is a no unique constant means, of course, there is a no unique index. Okay, if there is no index. Another one serial number, and here I will be applied unique. Then your index is created. Now your index is created. So then advantage of okay, unique index is what now? Suppose in serial number, in this case, I'm not using any unique constant on my column. So whenever I didn't apply any unique constant on this column, can you tell me this column can accept a duplicate data? Accepted now? Yes. Suppose here 1 and 1. Here I can insert next time 1 only. But here you can insert 2. Here 2, here 3. Here 2, here 4. Here 3, here 5. So you can 3. Now you can insert 3. Now you can insert 4. Insert 4. Insert 5. 5. 5. So in this both the columns, how many numbers I saved here? In serial number both columns, how many numbers I saved? Yes, 5 numbers only I saved. Okay. So here 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5 only saved. But what is the differences here means? Here no unique index. That means unique constant is not applied here. That's why there is a chances to occur duplicate data. But here, when unique index is there, that means we applied. That means what now? Unique constant already we discussed. Unique constant, what it will do? Duplicate values are restricted. If user try to insert duplicate data, but the duplicate values are not allowed. So now this is what it was going to be happen. Okay. But when it was there like this, at this moment, suppose you need to test now. Okay. If you wanted to here, select a star from some one of my table, for example, okay, EMP table where serial number is equals to 3 if I call. Okay. And this request, if it is applied on a no unique index column, that means there is no unique index column, then what it was happen, this condition will be checking with each and every value. Already we knows. So one is checking here. One is comparing serial number 1 equals to 3, false. Next 1 equals to 3, false. Next 2 equals to 3, false. Next 2 equals to 3, false. Next 3 is equals to 3, true. So output will be 3. Next 3 is equals to 3, true. Next second output will be written. Next 3 is equals to 3. Next is also true, then 3. Next it will go to 4 equals to 3, false. 4 equals to 3, false. 5 equals to 3, false. 5 equals to 3, false. 5 equals to 3, false. So for our required data to fetching or to retrieving purpose, here all rows are checked out. That means total how many rows we checked out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means here 12 rows we searched here. 12 rows we searched here. So, and was our assumption, our assume is what now? Each row 1 second means here it will take only 12 seconds only it will take. Okay, now how much time it will take? 12 seconds. But the same thing, when I'm going to apply on my unique index column, then what it was happen? Now you can compare this. Now 1. So 1 is checking here. 1 equals to 3, false. Next 2. 2 is checking here. 2 equals to 3, false. Next 3. 3 equals to 3, true. So that means this row immediately, okay, this row immediately fetching from your table. Immediately fetching. The answer is 3. So that means to getting of this information, how many rows we searched here? Only 3 rows are we searched here. So that means 3 rows means each row searching 1 second. Then here time it will be take 3 seconds. So that means what you concluded here, when we have a more duplicate data or more duplicate values are there, then searching time automatically increase. When we don't have a duplicate values, then searching time automatically decrease. Yes or no, guys? Is it correct? When we have a duplicates, then my searching time will be increase. When there is a no duplicates, then my searching time is decrease. Is it right or wrong? Yes. So this is the way the unique constant will be helping us. The searching time will be reduces. Okay, so automatically my searching time is reduces, then my data quickly I can access. Okay, so this is what we called as here. Okay, this is what we called as here unique index or unique index advantage. Okay, but how to create this is a syntax. Let me come out and see. So we have one more table here. Select a star from DEP. It is one table is there. Okay. Suppose first I have to check on this table. Do you have any indexes here? Observe. Do you have any indexes on this table, guys? Come on. So no index. When there is a no index, then I will create one index now. Create unique index UI. Okay, on DEPT of department name, I'm going to create it. So index is successfully created, and now see index is created or not. Now index is created, guys. Come on. Yes. After created, let me go. Suppose are you inserting some data into DEPT table? So values of department number 50 and sales location is HYD if I'm sending. Okay, now So whenever we send it like this, what it was happen, you can see here in my department name column. Okay, in my department name column, already sales department is already existing here. Okay, but if you try to insert it one more time, is it accepted here? Is it allowed this sales information? So it is not allowed. So not allowed means automatically, okay, this data will not accepted now. It was showing what now? Error. And can you see one point here? Unique constraint is violated, but what is my constraint? Okay, what is my index name here? Can you see? Yes. So UI. So unique index is violated here. And now from this table, if I want to retrieve my data, okay, what it was happened? Very simple. So now select a start from, okay, DEPT. Suppose where D name is equals to, I'm going to call here sales. Then sales it will become, but sales how it was searching here means, so accounting searching, accounting is equals to sales, condition false, research is equals to sales, condition false, sales is equals to sales, condition true. So in the three searching levels, we find our data. But after finding your sales, the operation will be checking or not checking out. Come on, guys. Once we found my data, the next operation is there. Operation is checking or not checking? Yes. It is not checking. Why is it not checking? Yes, because of reason it is a unique constraint. So server will knows that it is a unique index. Unique index means what now? There is a no chance to have a duplicate. Yes or no? There is a no chance to have a duplicate. Suppose you have a 1 lakh rows means 1 lakh rows are different. So that's why there is no chance. Once you find out your required data where it is, then remaining data I don't want to search. Okay, no? So that's why what it was happen, the searching time automatically reduces. Okay, so this is one way of unique constant how to, sorry, unique index, how to helping us to fastly retrieving our data. Okay, so this is first I have to create an example. Okay, after that you will call that was in DEPT. So our D name is equals to suppose sales. Okay, that will be testing now. So this is what we called as unique index advantage here. Okay, now, and the next one we called as, what is the next type here? Functional based indexes. So functional based indexes, what it was say guys here. Okay, so the definition first observe. So when we created an index object based on function, based on function name. So then it is called as a functional based indexes we called. For example, how to create means create index and index name on table name offer, and here I need to send my function name offer, sending what now? Column name. Okay, so based on the function wise, if I create my index, then it is called as a functional based index we call. Okay, and once it is created functional based index like this, okay, so how and how it was created and how it was working means, here carefully observe. The same as when come to our table. So one of my tables, select a star from EMP. So on this table, I have some indexes already created in EMP table. So these are some indexes are there. And now I'm creating functional based index now. So create index fi, index name on table name emp offer. Here my function I am giving here upper offer ename column. Okay, upper offer ename column. When I'm using to execute this, my index is successfully created. And let me come out and see your index. So functional based index is created now fi. And what is this means? This is called a system, okay, identification of your function. That means which function you applied the function identification number. Okay, some address here that was generated by who? System. So the function identity we called. So function identity automatically system is generated whenever you want to apply so and so function on particular column along with your indexes. So this is functional index we created. After created, let me see what it was happened. Suppose if I'm going to asking here, select a star from EMP where my function, whatever I used here, the function name, upper of ename is equals to, if I'm giving here Smith, I'm giving now. So when I'm giving Smith, what it was happen, the Smith when I'm passing, then this value, actually my condition is what now? Uppercase characters. So only uppercase characters only considered by your server. So it never consider your lowercase characters. Okay. So then what it was happen, your server will not finding any Smith, which was small case characters. Okay. So it doesn't go to be check it out any information on the table. So now, but here when I'm using the uppercase and same as uppercase characters, if I followed here, then upper of ename is equals to uppercase, then condition true or false? Tell me guys. Now condition true or false? True, and it will be checking your uppercase, and now immediately the data will be fetching from your table. So here when I'm giving small case characters and was not satisfied with my upper function, because upper function is always returns uppercase characters. Okay, now, but a small case character I was given, so it doesn't consider this request here. And when I'm using the function along with function Smith, and here I'm asking upper names and my value also upper. So upper is equals to upper, then condition will be true. Then true means the data will be found and retrieving from your table. Okay. So this is what it was called as here. Okay. Functional based index we called. Okay. Functional based index we called. So this is what it was say. No rows. And here it was allowed. Okay. So these are the different types of your B-tree index in different formats and different ways we can go to create it here. Okay. And the next one is called as the second one. The second type is called as what now? Bitmap index. So this bitmap indexes, bitmap indexes, how the bitmap indexes can be created and how these bitmap indexes are working on database table by while retrieving the data. Okay, now, right. But first of all, we will see some information about bitmap index. What is what? If you understand the theoretically, then practically you can easily understand. Okay, now. So first I will explain to you theoretically when we called it is a bitmap and how these bitmap indexes are created. Okay. So yeah, remember one thing. Basically, bitmap indexes are created. Okay, now. So these indexes are created. Okay, based on low cardinality low cardinality of columns. Okay, so which cardinality is low, okay, on those columns we will be created bitmap indexed to improve the performance of database. Understand that? to improve the performance of database. So here, sir, what is the mean by cardinality? Okay, this is important for you. So what is cardinality here? What is cardinality? Cardinality is nothing but, guys, here it refers unique or uniqueness or distinct values of a column. Okay, now it refers, okay, the distinct values of a column in a table. Okay, now otherwise somebody is also saying like here it refers the uniqueness for the uniqueness values of a column in a table. So can you remember, guys, here distinct keyword we already used it. Okay, tell me, when I'm using this distinct keyword, what it will be happen, guys? Distinct keyword when we want to use, come on. Distinct keyword when I'm applying, what it was happen. So in your column, if any duplicate value was there, those duplicate values are eliminated. Those duplicate values are eliminated, and it was considered or counting only unique values. Okay, for example, let me observe. Suppose in our table, okay, one of my column is called as a job column, you can see. When I call job column directly without a distinct keyword, that particular job column we retrieve. And now can you see, do you have a duplicates here? It was retrieving your data including duplicates now. Yes. So it was taking including duplicates. So now suppose on this, if I apply here distinct, okay, and job, if I apply, and from EMP, then you can see once I apply distinct keyword on job column, then do you have any duplicates here? No. So that means distinct keyword is nothing but what now? Eliminating of duplicates and counting only unique values only countable. So duplicates are not counting here. It's counting only unique values. So that is what we called as a distinct value. Otherwise, uniqueness values of columns. Okay, now. So duplicates are not considered here. Okay, only consider unique. Okay, duplicates are eliminated, not considered. So now carefully observe. This is what a cardinality definition. But sir, how I want to know it, the particular column cardinality, how to find out? Okay, how we can find out the cardinality of a particular column? Means there is a formula. There is a one formula was there. Okay. What is the formula finding cardinality means? Okay. So cardinality of column is equals to, okay, is equals to number of distinct values of a column, value of a column by number of rows in a table. Number of rows in a table. Okay, now. So this is the formula about your how to find out cardinality of a specific column. So what it was saying that number of distinct values of column by number of rows. Okay, let me see. some examples now. Suppose I need to find out cardinality of a EMP number column. I need to find out. So EMP number cardinality, how much that I need to calculate now. Okay. When I want to calculate here, carefully observe and come back to your table. This is my entire the table. In this entire the table, EMP number, you can see this is my column. So in this EMP number, okay, first, what is my formula here? Number of distinct values of column. And now tell me, in this column, how many number of distinct values are there? Count. Come on, guys. $14. So here number of distinct value means each and every value is a distinct now. Is there any duplicate values there here? Every number is a different now. Yes or no? Yeah. So that means what I want to say, 14. 14 by, next what I'm asking, number of rows. 14 by number of rows. Here, how many rows are there in entire the table? So 14 rows. So 14 by 14 is equals to how much here? 1. So that means my cardinality value of EMP number, how much cardinality value of EMP number? 1. Okay. Like this, now we can find out another one. So cardinality of suppose E name, if I given now, for example. So E name column, if I applied cardinality, then see distinct values. How many distinct values are there here? Yes, as per this table, I'm telling. As per this table, again 14. Again 14 by 14. So the cardinality of E name is also 1. Okay. So let me try. One more you can see that cardinality of a job column, I will be find out. So when we find out job column cardinality, then check it out job column, the next column. So how many number of distinct values can you find out? Five. Only 5, because already we done. See, already we done distinct. Apply distinct. Distinct applied. How many values are there? Come on. Yes, we have a 5 values only. So what I want to say 5. So 5 by number of rows are 14. Then you have to, how much it will come here? 14 zeros, 14 0, 0.14 threes are, okay, and 14 threes are 14 4 are 4 fours are 14 fives are, okay. So 14 fives are, so 0.35. Now tell me in these 3 columns, which cardinality will be low? Which cardinality will be low? Job column. So here job column cardinality will be low. Okay, so that means here carefully observe. One note point should be remember all of you. Okay, in this how the people will be designing your indexes means how they design indexes on table. When your cardinality is more than or equals to 1, then they will be preferred to create on the type of columns Which type of mechanism they applied? B tree. When this cardinality is okay, less than 1, if it is there, then preferring by people, okay, bitmap. Okay, so now somebody is asking, sir, when I want to apply B tree index, when I want to apply bitmap means when your cardinality depends on. So cardinality when greater than or equals to 1, then B tree will be giving high performance. B tree will be giving high performance here. Okay, now? And when you give it less than 1, bitmap will give it here high performance. High performance will give it here. Okay, now? But here low card tree indexes, okay, the performance wise not that much good. Okay, now? The performance is not that much good. And high cardinality of columns, if you applied bitmap index, okay, and that is also not that much good. The performance wise not good for us. Okay, now? So that's why, so more than 1 or 1, B tree indexes will give a good performance. The performances will be highly, okay, it was highly performance will provide. Less than 1, bitmap is suitable. Okay, that means these two techniques, B tree technique, bitmap technique, how we can use means based on that column cardinality value how much, based on that the people will be decided which index is better to apply on this column to improve the performance of database. Okay, now? So based on that logics, okay, they will be choose either B tree is good for us or bitmap is good for us. Okay, now? They will be decided and applying. Okay, so this is what it will be asking. Okay, you just, if anybody asks you, you just go to give it like this. So now here 1 1 is there here. Suppose if 1 1, if I created bitmap index on 1, then my performance is degraded. Okay, na? And searching time is more. Because searching time is more. Why, sir? Means every unique number I need to compare. Every unique number I need to compare. So that's why searching time is more here. But at the time low indexes, if I applied bitmap, then what happened? Okay, then I didn't search each and every value. That means if you have a duplicates, I don't want to search duplicates. Here only the uniques will be checking and remaining duplicates are eliminated. Okay, na? So there is advantage. That how it is, I will show you one example, then you can understand. Okay, na? Don't worry about that. I will give one example how the bitmap index, low cardinality of column, advantage is what, and how it was searching. Okay, now I will show you one example explanation. I will give it, then you will understand. Okay, but finally, what I'm saying here in this part, okay, so bitmap indexes is creating on what now? Low cardinality of columns, and your cardinality is nothing but uniqueness or distinct values only counting here and consider here. And the formula of cardinality, how to get means the cardinality of column is equals to number of distinct by number of rows in a table. And finally, after finding your column cardinalities, which column is the lowest or low cardinality value is there? So there we will be prefer your bitmap, because as per the definition also, these indexes are created on low cardinality of columns to improve the performance of database. Okay, so that's why I'm going to checking these two, but these are 1 1, and third one is less than 1. So my priority is always less than cardinalities. Okay, now, right? And this is your syntax and formula of cardinality. Understand? This is called a syntax or formula. Somebody confused here. Your formula is nothing but syntax here. Don't confuse. Okay, now? Right. So this is the way cardinality calculations, and based on that you can find out. So finally, if you finding the low cardinality, okay, on that low cardinality of column, suppose when I created my bitmap index, what internally happening here observe. Okay. So when we created a bitmap index, on low cardinality of column, nullity of column. Okay. Internally system is preparing a bitmap indexed table, a bitmap indexed table with bit numbers, okay, 1 and 0. Okay, what is my bit numbers here? 1 and 0. Okay, so what is this 1 and 0 bit numbers will representing here? Means that here observe here. Okay, so here bit number 1 is represent condition is true. Okay, and 0 is represent condition is false. Okay, now so your 1 is nothing but condition. When it was condition true, then it was written bit number is 1. When your condition is false, then it returns bit number 0. Okay, right. And here your bit number 1 means what, sir? Means that, so here bit number 1 is nothing but, okay, is nothing but how it will be representing means is nothing but it's called as a row ID in a table. So can you remember in B-tree index we are using asterisk symbol? Can you remember guys? In B-tree we're representing asterisk symbol for row ID purpose. Yes or no? Come on guys, yes or no? So here your asterisk symbol, how it was represented by people, that is representing row ID. Row ID is nothing but what now? Your page number. So row ID is nothing but page numbers in textbook. In which page number your required topic is there. Okay, now so same as the asterisk symbol is representing page number, is nothing but row ID. So based on that asterisk row ID, directly will go and fetching our data from the table. That is a B-tree. Same as here also, 1 is representing what now? Row ID in a table. Okay, so that means wherever 1 is there, the 1 is representing row ID. So based on row ID, directly will go to the table and fetching my required row immediately. Okay, now so this is what we called as, guys, here. So cardinality and definition, syntax, finding how to calculate, and this is some information. Once you created your bitmap index on low cardinality of column, internally what it was happen. So after your system is preparing bitmap indexed table with 1, 0, then after everything will be prepared, and that index table, that means that bitmap index table, who will use it? Means your Oracle server is use it. When the Oracle server will go to this bitmap index table, when user retrieving some data. So whenever user required some data from a table, based on the request, your Oracle server will go to bitmap index table and checking your required data where it is. Okay, now same, it is also like a publisher in your textbook who was, okay, publish your textbook. Those publisher only preparing index page, and that index page who will utilize? Users, readers. So readers are using that index page which was prepared by publisher in your textbook. Okay, now so here also your system, whatever it was prepared here, B-tree or bitmap indexes in your table, those B-tree and bitmap indexes who are using? Readers or users. That means we are programmers or users are using that facility. Understand now? right? So this is what bitmap indexer information, guys. Okay. But now, sir, we will see one example how this bitmap index will arranging your index table data with the bit numbers 1 and 0, and how it will be fetching your required data fastly. Okay, right. But that example we will see in tomorrow session, guys. So tomorrow I will give example on that. Okay, and after this indexes, we have one more topic. Then after I started normalization concepts. So once normalization is finishing, then we enter into PLSQL. Okay, right, guys. So I stop it here and will be continue on tomorrow with example of a bitmap. Okay, right, guys. Thank you. Thank you so much. And if anybody have a queries, stay there. Mhm. Okay, right, guys. And so having any queries, you can send it. Krishna is asking, okay, how many sessions? Okay, Krishna, that 15 to 20 sessions it will be on PLSQL. Okay, right. So whatever it is, large data, small data, whatever it was. So just you have to find out the formula and find out your count of star. Okay, if you have a number of rows are there, then select a count of star. Then automatically it will be finding. Okay, right. So distinct keyword apply, distinct values will come to you. Based on that, they will calculate it cardinalities. Okay, now right. So dense rank you should be used because dense rank Manasa it was giving accuracy ranking numbers. Okay, now if you want it accuracy, then dense rank is preferred and rank function is not using. It's a outdated here. That extension we called as a dense rank. Okay, right. Oracle is not a case sensitive. Who said Oracle is not a case sensitive? Oracle is a case sensitive. SQL queries are not a case sensitive. Okay, na? SQL queries I said. Otherwise, you can once refer SQL language notes. Whatever the queries we writing inside query, update query, alter query, create query, these are not a case sensitive. Okay, na? Right. That's depending on your requirement, Manasa. So depend on your requirement, which column wise we need to do partition. That, for example, salary wise, department numbers wise, you need to find out some salary, highest salary people. Then your partition on department number. Suppose jobs wise, you need to find out senior most employees. Then your partition you can apply on jobs. Okay, now. So it's depending on your question on which basis you want to find out what that you have to decide and apply your partition by on that column. Okay, right. So some examples I already given in the notes that read that no examples and practice ones that queries you can understand on which column wise we want to do. Okay, right. The next or anybody. Clusters we are discussing, but Narasimha SQL loader we are not discussing here. That is a DBA concept. Okay, here cluster next concept is cluster, but loaders we are not discussing here. Okay, right. Or anybody is there, guys, here? So having queries, send it, otherwise log out.